Hello everyone, and welcome to today's webinar, Getting Started with Windows on AWS. During the presentation, we invite you to write in your questions using the Q&A box on your panel. These will be collected during the presentation, and we will address some of them at the end of today's presentation. Slides from today's presentation will be available afterwards, and I will have further information on how to obtain these slides from today at the conclusion of our webinar. With that, let's get started. First, let me introduce today's presenter. Today's webinar will be presented by Miles Ward, Ecosystem Solutions Architect here at Amazon Web Services. Miles Ward is a three-time technology startup entrepreneur with a decade of experience building global-scale analysis infrastructures. Miles has been at Amazon Web Services since 2010 and is responsible for designing and developing AWS solution architectures relating to big data, social analytics, multi-tiered storage, high availability and disaster recovery approaches for RDBMS systems, and cost optimization using Spot. Miles is a patent holder, recently published the AWS SQL Server on Amazon EC2 white paper, as well as a consummate geek. So with that introduction, I will now turn our presentation over to Miles.
Good morning, everyone. Thank you for joining Amazon and taking some time out of your day to review getting started on Windows on Amazon Web Services. So I'm looking forward to walking through a couple of different sort of major categories. First, because if you're getting started, we think most of the time that means you're not only getting started with us, you're sort of getting started in a project or getting started in a new design practice. So we'll do a quick review of what is Amazon Web Services, what's the product that we've brought to market, and how are those systems stitched together in a way that provides value. We'll also look at how enterprise customers, significant Windows users, and other kinds of macro scale businesses are leveraging Amazon Web Services to solve some of their big problems. And then we'll do a very specific dive through how Windows works on Amazon Web Services and some technical details about making that smooth. Again, we'll be using this presentation format. If you have questions or if any of this prompts a new idea on your side, please don't hesitate to write in. We'll take some significant time at the end for Q&A. So what is Amazon Web Services? We're a cloud computing platform. Amazon has built, we believe, the most significant infrastructure as a service utility available on the web or anywhere on the planet today. AWS allows you to take advantage of scalable, managed resources to build your business without the undifferentiated heavy lifting of racking and stacking computers or building complex networks or other kinds of more inefficient approaches. So Amazon Web Services has been built on top of the Amazon.com infrastructure system, took some of the best practices and learnings from that very scalable, very global footprint, and it has made it available to customers for use in their own systems. Amazon Web Services is now a system in use in 190 countries. There aren't many more than 190 countries on the planet, in use by some of the very biggest businesses in the world, but very importantly also in use by hundreds of thousands of the smallest businesses in the world. So you can get started very easily. You can use only the sort of parts of this system that are useful to your use case. We have businesses that are using us for a myriad of different applications, and we'll go through how some of that stuff works. Every one of the companies on this slide, and again, hundreds of thousands of others, have built their businesses or are building very significant customer-facing applications on Amazon. This system is not small, and really we can pretty easily let the numbers speak for themselves. This is a pretty recent view at just the growth of one of the 26 different services that we offer, Amazon S3, which is a storage system for the web. It allows you to upload data and serve that out to a URL or to make it private for archival of content. That system today holds some 566 billion unique objects and serves a request rate of in excess of 370,000 requests a second. something that's one, very difficult to do on any kind of physical infrastructure, but it's something that we're able to do starting at just 14 cents a gigabyte for storage on your side. So very, very successful product and a great example of our hockey stick growth into consuming these critical workloads for real businesses. That growth is echoed in the rest of our services. A good example of that being that when Amazon was a year 2000 global $2.76 billion enterprise, they had a very significant infrastructure stack, racks and data centers full of computers in order to be able to serve that load. Every day, Amazon Web Services adds equivalent server capacity to the systems used by Amazon.com in 2000. That's a gigantic amount of infrastructure and a growth rate that puts us in really in a leadership position in this marketplace. So why AWS? Why, sure, it's growing. There are a lot of customers using it. We think we've built a model that allows some pretty significant changes to the way businesses plan and take value from web infrastructure. So first difference with us, there's really no upfront capital expense. Rather than leasing a building and signing contracts to service the building and buying computer hardware up front, we don't have any of those kinds of costs. You pay for server instances, virtual machines by the hour, and only for the hours that you use them. You pay for storage by the K. You pay for network bandwidth by the individual K. So very, very granular, very specific pricing. That's also very inexpensive. So many businesses have been able to build their first step infrastructures in our free tier that includes 5 gigs of storage at no cost and other kinds of benefits. That low variable pricing also allows you to tie the value of what you deliver to customers back to a much more specific actual cost on the AWS side, so you can be much more careful about infrastructure planning. You only pay for what you use with us. There's no contract or sort of hard requirement. There's no lock-in on our services. So if you decide you want to use something else, or if you don't really need the infrastructure that you've provisioned, you turn all that off, you stop paying in the very next hour. All of this is self-service. Every part of our system is accessible by web API. We really build the APIs first. So it's very, very straightforward, not only to get started and use a user interface in order to be able to provision new systems, but to write software that deploys hardware. Very different model than everywhere else. This controllability makes it very, very easy to scale up and down. Lots of folks can make it so that you can build systems relatively quickly. We make that minutes away, and we also let you scale right back down to 0 if that's what you need at a given time. All of that flexibility should really radically improve your time to market for specific services. So we've had customers that have brought online things in absolute breakneck speeds that are pretty impressive, large-scale global footprints. So that platform, this suite of different tools, there are actually 26 independent products today, and we add new features and services at the average rate of about 1 every 3 days. There's a new feature released today on Amazon over the average of this year. So it's very rapid growth rate, very rapid adoption of the platform, and we think we've built a suite of services that should let you bring almost all the major applications, both commercial off-the-shelf things like Windows and other commercial applications, but also any applications that you're developing to bring those to market in an efficient way. We've also deployed this infrastructure in a pretty broad variety of spots. This slide shows just 4 of the regions in writing. There are actually 7 of them today. So U.S. East, U.S. West in Northern California, U.S. West 2 in Oregon, Dublin, as well as Tokyo, Singapore, and our government facilities that are here in the States called GovCloud. We also have a CDN built in called CloudFront that has now 23 independent locations. So if you look at that, then it does build. If you look at that stack of services, we've really built a set of a set of physical infrastructure globally that allows you to build exactly the same kinds of systems and distribute them across the planet. Get them closer to your customers, get them lower latency to your remote offices, deliver value to your customers where they're at. Above that layer, we've built a set of low-level building blocks. Amazon EC2, where you rent servers by the hour, S3, where you can store your data, ELB, an elastic load balancer for distributing traffic, and Amazon RDS, a managed database environment. Those low-level building blocks then allow higher-level aggregations, things like elastic MapReduce for a managed hosted Hadoop environment built on top of EC2, or SNS and SQS services for notifications and for queuing that are built on top of this global infrastructure. Those services allow you to much more rapidly build and deploy high-scale, high-value, high-performance systems. We also have a set of authorization and federation tools called IAM, a monitoring service called CloudWatch. The list is really quite long. We've also built and really worked together with partners to deploy integration tools in all the major programming languages, .NET certainly, integration tools for developers like our plugin stack for Visual Studio, and a whole rich command line interface. So any of the ways that you want to interact with our infrastructure work very, very well. Enterprises, as a market segment that use this system, have largely looked at the cloud as an extension for their data centers. Rather than building data center number 17, they'll add AWS as a more scalable, more cost-effective, quicker-to-market version of that. Most of that has to do with the real challenge around capacity planning. If you have any experience buying the physical hardware required to bring a service to market, typically you're building and buying in very stair-step, individual functions. They go through a procurement department that takes months at a time. Depends on your environment, but we've found a lot of folks take quite a lot of time with that. When you're buying and utilizing infrastructure by the hour, you get to make much more nimble decisions. You get to much more closely follow actual usage so that you don't end up either with waste, too much capacity that you're not putting to use, or problems, downtime, customer dissatisfaction when you have more usage than you really can handle. Really a critical part of that is it's really not all or nothing. So a lot of these enterprises, I think when they started, were very concerned that if they used the cloud, that meant they had to move all of their infrastructure to the cloud. It doesn't work like that at all. Because we're very granular, we'll allow you to build each individual little application on our platform, really following a pretty standard model of evaluating which apps are no-brainer, which apps are the ones that just make perfect sense on Amazon, and which ones are more of make more sense as a phased migration to really evaluate the real use case and the real needs. When you're building new applications, it's really very obvious at this point to build in a cloud-ready design. In a lot of ways, service-oriented architecture, high availability designs, programmatic management of infrastructure is the norm in the cloud or out. So it makes a lot of sense to follow those design paradigms as you build new applications to take advantage of the higher efficiencies available there. So for your existing applications, the no-brainer ones make a lot of sense. If you take, if I can have advance to the next slide, please. There it goes. So there are quite a few applications that just make obvious sense in a migration to the cloud infrastructure. So dev and test. You're probably used to building a development environment that's much smaller than your standard environment. In our environment, because you're only paying by the hour, you can stand up a whole duplicate copy of production for 2 hours and run your test, and then turn it all back off. You only pay for those 2 hours. Any self-contained web applications, something that lives in a WAR or an ASP deployment or something of that kind, really typically very, very high performance in our environment. Social media product marketing, any of the kinds of web accessible social content makes perfect sense. Customer training sites, anytime you want to deploy software without installation, without setup, so customers have quick access to a pre-configured environment, like training classes and things like that make perfect sense. Video portals, clearly video is a very, very effective standard on our environment. We also have lots of folks running large-scale software downloads, trial applications, and certainly the big data analytics and other kinds of systems where it may be prohibitively expensive to grab access to infrastructure. So we really think that most folks are following kind of a 6-phase migration strategy, sort of assessing their state in cloud, walking through a proof of concept with an application that seems like a clear fit, migrating their data, migrating their applications, and then drilling down in their design to figure out if there are better ways to leverage the nuances of the cloud for higher efficiency, and then repeating that cycle as they go through each of the different applications that make sense. One of the things that we think a lot of people haven't heard from us yet is that getting started with Windows is really very easy. We've done a lot of work together with Microsoft. Microsoft is a very significant partner of ours in this process to make it so that really when you look at an EC2 instance, a virtual machine that you rent by the hour, and the Windows Server operating system, very, very robust, very high performance, really designed to meet the needs of the global businesses in the world. But those two together put a big smiley face on your average user. Amazon's built a set of pre-configured Amazon machine images, or AMIs. That's real similar to a VHD or another operating system image format. With those AMIs, you can start a running, fully supported, fully licensed Windows Server in minutes. It really does take about 6 minutes. The amount of time that it's going to take for me to talk through it, if you follow on these slides, I'm willing to bet you can probably get one running. So just to sort of quickly take you through what that looks like. If you've got our Amazon Web Services portal, that's aws.amazon.com, you do need an account. That's a very simple sign-up process. It includes collecting your credit card information and establishing a set of security credentials so that you can access our tools in a secure way. Amazon's built really absolutely best practice, best in the world security environment, and made it so that these tools are very, very secure. If you take a look through, we have an AWS Security Center that you can search for in that search box up on the right, and take a look at the white paper about security there that walks you through each of the different details about how we've secured our infrastructure and built a system that allows some of the most secure facilities in the world. So once you've created an account, you sign into our management console. It's that little blue link at the middle and the top of the page. Management console is the web user interface. That interface is one view of which there are many into our infrastructure. You can certainly do all of the steps I'm about to describe by way of our command line interface. You can write a .NET application to do all of these steps in code. That's one of the big differences between these kinds of systems and the racks at your office. No one has to run down the hall to plug something in to make it go. So once you log into our systems, then you'll get into our management console. This is the EC2 control page. You're looking at the dashboard here. And there's a big yellow button that says Launch a New Instance. You also get a bunch of statistics. So the right-hand side, it shows you how many servers are running, how many of their network-attached drives or EBS volumes are present, how many of your SSH key pairs, those are encrypted credentials that we use to authenticate your access to a Windows server. When you launch an instance, you get a quick start guide. It's a system for walking you through, a wizard for building a new virtual machine. That quick start wizard includes links to the Amazon machine images that Microsoft and Amazon together steward to ensure that you have very recent versions of their applications and of their operating system versions. So we have Amazon machine images for 32-bit and 64-bit instances. There are different servers that run different kernel depths. We also have Windows AMIs that have SQL Server Express and IIS, some of the basic pre-built applications. Then we have more sophisticated AMIs that have more software built in. Things like SQL Server Standard, which is an application that I'm sure you're familiar with for storing data on the web. You can not only use these built AMIs, but you can start from an Amazon machine image like this, install your software or the software that you've purchased from partners or other kinds of applications, open source applications, and then rebundle your image, make a new version number of it, and then from there start new machines that follow that template. So these are really a starting place for you to build an infrastructure design that fits your use case. So if you selected this, you'll go through a 5-step wizard where you'll create a key pair. That'll allow you to securely access the infrastructure. You'll also pick which instance type. There are 13 different Amazon instance types today, going all the way from a T1 micro, which is a shared bursted infrastructure, very, 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 sort of inexpensive. All of these systems include the Windows operating system license as an hourly rate bump on top of the standard instance rate. Very, very easy to use and very easy to license. So the T1 micro instance being the smallest, you can go all the way up to a CC2 8X large, which is a 16-core, 60 gigabyte of memory, 10 gigabit Ethernet machine. Very, very high performance for your biggest databases and applications. Once you've created an instance, so now I'm looking sort of after the wizard is done, you'll see it show up in your list. One of the things in the list that I've taken a picture of here, I have Windows machines and I have machines running other operating systems. This is a heterogeneous environment. If you've built systems that take advantage of more than one operating system, you can run those right next to each other in our environment with no problems at all. Once you've created a Windows machine, we have a process where we generate a random password for that instance. It follows the Windows sysprep utilities. It takes a couple of minutes for that to run. So once you've created a machine, maybe grab a cup of coffee. As you come back, the system will be ready to expose the password to you. You'll share with us your SSH key, your encryption credential that allows you to access the system, and we'll pass back to you an administrative password. After that handshake, you're able to change the password. You are administrator on a real full Windows 2003, 2008, or 2008 R2 server instance. So this next piece here, if you look, is the process for retrieving the password. If you connect to a machine, it automatically prompts you, would you like to retrieve the password? You also are able to download a shortcut file to use remote desktop in order to access your server. It's connected to the web. You'd use the default security groups, which are a built-in ingress-only stateful firewall that controls every individual virtual machine you start with us. You'd open the RDP ports and then be able to connect by remote desktop into your machine. Once you've done that work, you're in. It's a real computer. There's no strangeness there, no unusual version. You can install any applications. Really, really a very powerful, full-featured experience. Nothing sort of limited or gammuted. So what's that stuff cost? It really is very inexpensive to run this infrastructure. Again, we described there are several different instance types. M1 Small is a great place to start. Has a full dedicated virtual core, 1.7 gigabytes of memory for a very sort of snappy logged-in user experience, and only 12 cents an hour, including the Windows license. As you go up to larger instances, you're paying more, but you're certainly getting significantly higher performance, again, all the way up to our 16-core boxes on the Cluster Compute 8XL. Each of those prices are by the hour, and the licensing for Windows is included. There are other pricing models. So we have reserved instances that allow you to pay a small fee upfront in order to receive a discount over the long term for a given instance if you know you're going to run it for a long time. We also have the opposite of that, a spot market, where you bid for unused instance hours, typically at a pretty significant discount against the current on-demand price in exchange for the flexibility where if we need that instance capacity back, we can turn your machine off. So very, very flexible pricing allows you to dial into exactly what it is that you need from your infrastructure. So we've heard from a lot of customers that they think that Windows in the cloud or Windows on AWS must feel different, must be strange. This is a full, real, fully licensed, Microsoft-supported Windows Server operating system. again, 2003, 2008, 2008 R2. We're licensed via the SPLA licensing agreement with Microsoft, which means you don't need CAL for accessing this software. The CAL is included in your rental of the license from us by the hour. We also allow SQL Server Standard by SPLA as well. You can use another service called License Mobility if you need to move licensed Windows software onto AWS. There's a form that you'd fill out that allows your volume licensed, software assured applications to migrate onto the cloud. We have a whole network subsystem called VPC that allows you to build very familiar, very normal networks. That includes static addresses for your instances, your own definition of routing tables, the ability to close these machines off for access over anything but a hardened hardware VPN connection. Very, very effective at managing connectivity to the machines. We also have very, very powerful security groups for easy to configure access controls for each virtual machine. Each of these services, the Windows applications and the broader server platform, they work great on AWS. Active Directory Federation Services, SCOM, DubSus, SQL Server, Exchange, SharePoint. These workloads are in practice at large scale on AWS today. All of the benefits of a cloud infrastructure, we think, the ability to scale, the ability to change without any sort of bizarre limitations or constraints about how many of this or how many of that. We really thought that a lot of folks sort of thinking of Windows on EC2 would really think of the virtual machines as really the only service. Amazon's built 26 independent products, and they work together with Windows very, very well. So S3 allows you to do backups of your Windows systems as an incremental, very, very straightforward to use. You can easily copy the configurations of your machines back to S3 for 11 nines of design durability storage. Elastic Load Balancer makes it incredibly inexpensive to distribute traffic across independent data centers inside of our regions. Really makes it simple to build a highly scalable, highly efficient Windows fleet. We also have a service called VM Import. If you're already a VMware ESX user or Hyper-V today, you're able to take VHDs or VMDKs and migrate them onto AWS to take advantage of your current configurations and design. We have a whole system of connectivity options. All of these devices are connected to the public internet, but certainly if you want more direct or private or predictable connectivity, you can use Direct Connect to run your own dedicated lines into the Amazon Web Services fleet. That's available in the United States today in US East by way of our partner at Ashburn Equinix, and in US West in the Silicon Valley facilities for Equinix. So you'd run potentially a dedicated, very high performance line into those environments and make multiple redundant 1 gigabit or 10 gigabit low latency connections into the Amazon fleet. That really allows enterprises to build in the way that they're used to building with dedicated network infrastructure. We also have a very, very inexpensive, very, very powerful CDN service for taking the content that you deliver maybe by those Windows IIS servers and replicating it around the globe. This list isn't anywhere near complete. We have very, very sophisticated tools that have been used by big enterprises and small startups to use Windows in market to build great services for customers. A good example of that, Amazon.com, corporate IT. Our internal tools team has the option to build in any infrastructure that they want. They could certainly go buy hardware to do this work. They could certainly use some kind of third-party colocation facility or a managed service provider. When they wanted to deploy SharePoint 2010, they have the option. They decided to use the AWS service. They took very significant benefit from that. So they were used to sort of 4 to 6 week cycles for deploying infrastructure. They've reduced that down to minutes. They really had a hand-built server image process where they would go in and configure the machines. That's now totally automated. Their total annual infrastructure costs for the entire facility, all up, were reduced by 22% by moving to equivalent cloud resources, very significant savings for an application at this scale, and really radically reduced the operational overhead, particularly of server lease returns. It's one thing if you're going to buy the machines up front, but if you're leasing them for return, it's actually a gigantic physical problem to actually unplug the things and package them for return and ship them, and all of that physical work that's very undifferentiated and doesn't really deliver any significant value to the business. So if Amazon corporate IT can sort of make that choice and take a look at building sort of some of the bigger infrastructures, certainly your business can as well. There's a lot of information resources available. Amazon's built quite a lot of documentation and quite a lot of general resources about not only our platforms but how our platform works together with Windows. So there are some general resources for Windows on AWS at aws.amazon.com/windows. There's also some specifics on our Microsoft License Mobility Program, the system for bringing licenses into the cloud. That's at the MS License Mobility / there's also a link to that on the Windows page. If you're interested in the best ways to build and the architectures that others have used, we've built some very significant diagrams and documentation and white papers on our architecture page. So certainly take a look at that. That resource is something that our Solution Architects group, of which I'm a member, is very regularly updating. We also have a global solution provider relationship with Microsoft, so they have their own GSP page on AWS that is a great place to get regular updates as to how it is that Microsoft and Amazon are working together to deliver great value to you as a customer. So in sort of quick review, we really feel like given this technology stack, given our position and the sort of current growth rate, that Amazon represents the global cloud leader. If you're trying to do infrastructure as a service, there's really no better place to do it. We have a global footprint that is expanding at an incredible rate and really represents the best in field for these kinds of services. Enterprises and large businesses, startups, security-oriented folks in the hardest sectors, the people who have the hardest requirements, are really rapidly adopting cloud infrastructure as a way to solve business problems that really aren't solvable in many other ways. And really, Windows on AWS is very, very straightforward. Again, in the amount of time that I've been talking, it's likely you'd be able to start up a Windows machine, be logged into it, and getting some work done on your Thursday morning. Very, very efficient by paying only by the hour, by paying for only the storage that you use, by paying for only the network bits that you take value from. It's really a very straightforward way to get efficient access to resources, and really designed with the security features, the compliance features, given our PCI Level 1 compliance, ISO 27001 compliance, and FISMA moderate status, really have the enterprise features that are required to bring effective tools to market. So I really appreciate everybody sort of listening through that set. We've had quite a few questions, and I really appreciate everybody's participation and involvement. I'm going to go through and spend some time answering some of those questions. So thank you for bringing them in. And if you have any other questions, don't hesitate to write them in as we're going through this. We have a little bit of time to go through and catch your stuff. So a question that just came in is how backup and disaster recovery is done in this environment. So we looked earlier at starting a Windows machine. Let's take a simple example of a single server. You put your website on an IIS machine. You want to make a backup of it. That's a right-click in our console to create a new bundled version of your image. That creates an AMI. That AMI then is restartable in any of the availability zones. There are 4 different ones in US East, 3 in US West 1, and then a pair of them in all the rest of the regions. If one of our whole data centers goes offline, the availability zones, you'd be able to redeploy at a moment's notice in an alternate availability zone. If the regions one side of the country to the other side of the country are the place you want to do disaster recovery. And really, we've seen some places where that's a best practice design. You'd be taking snapshots of your data, backing up your applications to S3 in an alternate region, duplicating AMIs from region to region. All of those processes are in place at the biggest businesses in the world. Also very, very straightforward to build in some of the automatic replication things like high availability designs for SQL Server for mirroring and other kinds of pieces like that. We have another question about how the server build process is automated. So two different parts. One, there are actually multiple ways of pulling this off. We have a lot of customers that want the ability to have a machine turn on and start doing good work. That's called elasticity in our book. There are a couple of approaches to doing that. One, you can certainly pre-build the scripts that you want your machine to start and build sort of batch level application automation into your Amazon machine image. So bundle up a working version of the machine. You can also use scripting tools like Chef or Puppet. Those applications each have sort of Windows libraries for reaching in and automated. We have a lot of folks that are doing this in PowerShell. And there are also third-party application providers, partners with Amazon like RightScale and Stratus that do a good job of coordinating and building server images. So there's a question in here that I think outlines some of the confusion that some of our customers have about how these systems work. So when you have a small instance or a large instance or an extra large instance, each of those virtual machines has a license cost associated with Windows that's the right fraction of a whole machine in order to be able to pay the right amount, a right-sized license fee back to Microsoft. That's a pure pass-through. Amazon doesn't take any kind of cut or markup on that. And that license meter is only running when the machine is on. If you turn the machine off, you aren't paying a single penny for that license cost. Also, very important, none of the machine types, the smalls, the larges, the extra larges, none of them other than the T1 Micro burst or scale or are shared at all. They are hard isolated by our hypervisor technology so that if you get a 1 gigahertz core, you get all of that 1 gigahertz core. If you get 4 2 gigahertz cores, you get all 4 of those. There are no other customers using your cycle. So there's a question that also came in about adding resources to EC2 instances. Very, very important. So say you start with an M1 large machine, a 64-bit Amazon machine image that's got 2 cores, 7.5 gigabytes of memory. If you want to make that machine more powerful, you'd follow what's called a stop-start cycle. So you'd stop the machine, you'd disable it for a short period of time. You'll stop paying for the hourly compute time on that machine during this period. Once the machine is stopped, usually that just takes a couple of minutes. Then you're able, or a couple of seconds, then you're able to use the console or our API or our command line to issue what's called a modify instance command. You'd turn that large instance into an extra large or a quadruple extra large, and then you'd issue the start command, bring that machine back online. So you can very rapidly go from a couple of cores to 8 cores, from 7 gigs of memory all the way up to 68 gigabytes of memory. So we have kind of I think a great question about enterprises putting their sensitive data on the cloud and sort of Amazon Web Services calming the nerves. If you look at, and I've run private data center facilities before. I've been inside of physical infrastructures. I've seen how some of the biggest businesses in the world do this. Amazon has built an infrastructure where we are serving hundreds of thousands of distinct customers. We serve them at a very, very low touch. We serve them in an environment that's very, very controlled. If you go through our security documentation and you meet with our security folks, if that's the kind of opportunity that you have, as you go through the sort of designs of what's the physical security that's been developed, what's the infrastructure application control that's been developed, in a lot of cases these systems are significantly more secure than folks have in their on-premise environment. multi-factor authentication and least privileges access to the physical devices and separated logical and physical controls in the environment. So very, 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 very stringent, very, very controlled infrastructure, and really the sort of usage speaks for itself. I mean, if the Department of the Treasury can put their website in our application and they can store data about the Treasury inside of Amazon Web Services, if we can be PCI Level 1 compliant and hundreds of businesses can run credit card processing directly on AWS in sort of full view in partnership with Visa, that's the kind of thing that we think proves that this is an infrastructure that's very, very secure. We had a great, very, very, very technical question. I like to hear that kind of stuff, and sort of uniquely well suited since I wrote the SQL Server white paper. So someone here asks about best I/O performance for SQL Server regardless of durability. So I would certainly recommend that you take a look at our cluster compute instance types at 10 gig Ethernet connectivity, full bisection, zero oversubscription, non-blocking. You have a very, very high performance machine-to-machine network and improved performance in communicating with the EBS subsystem. We'd suggest for highest performance to SQL Server that you create multiple independent file groups, that those file groups data and log and tempdb all be located on independent logical volumes, and that you use up to 20 independent EBS disks, just like you'd interact with multiple disks in a LUN on a SAN, to bring all of that disk resource and attach it by network to EC2. You're looking at somewhere in the range of 2,000 to 2,500 IOPS for the cluster compute instance types, where on M24XLs and other whole host physical instances in EC2, you're looking at more like 1,000 IOPS. And again, the EBS subsystem is significantly write cached, and as a result, write IOPS performance, particularly write random performance, will be very efficient. The local ephemeral disks are a great target for your tempdb, are also good for other kinds of ephemeral things like cache or swap space or things like that. Another important question, really critical differentiator from us and other kinds of environments, has just come in about SLA targets. So Amazon Web Services allows you to provision infrastructure on demand, and we expose a significant set of control tools for programmatic delivery of infrastructure. An individual virtual machine is a failable resource. One server is made out of real physical components. If a hard drive dies or a processor fails or memory fails, that virtual machine that is supported by that physical machine will fail. We have no SLA on the uptime of an individual virtual machine, and we don't think if you're building any kind of physical infrastructure that it really makes a whole lot of sense to have any kind of SLA on any normal single isolated physical device either. They're all made out of breakable building blocks, and even if you spend 10 times as much as on a specific dedicated physical piece of hardware that may be slightly higher durability, by and large, you'll always have some kind of a situation where the machines can fail. So what we've done is built a system where you have infinitely flexible control over deploying virtual machines on demand in reaction to actual events. And as a result, you should be able to deploy new machines to replace other machines that fail, to load balance against clusters of machines, to distribute traffic across multiple small virtual machines that are actually on sort of separate physical infrastructure in our environment, where if you're virtualizing in yours, they may be lots of machines on the same boxes. So in our environment, the big SLA, the important piece, is not some kind of an SLA around an individual failable physical device, but an SLA around those aggregated control tools. So EC2's API has a 99.95% availability SLA, very, very important set of controls. S3 for access to the data has a 99.9% SLA. Those are very important, very stringently held SLAs. We're not in the habit of violating them. So very, very, very important that you approach building things in a cloud in a way that follows that more more flexible design and an environment where you're building things on demand. We had another question about scaling the network to achieve infinite flexibility of the bandwidth. So in EC2, every virtual machine comes with a certain sort of subset of network bandwidth, very, very high performance connectivity back to the internet, very, very high performance, low latency connectivity machine to machine. Inside of EC2, in the standard fleets, you should be looking at something like an average of about a millisecond of latency inside of an AZ. And there's also very, very low latency, very high performance connectivity between the availability zones inside of a region. Those instances are connected and are typically at very high utilization inside of a multi-tenant network environment. So it is possible to have someone in your rack or someone in your machine use a bunch of bandwidth. You'd see that as latency or a compression of the bandwidth that you have available. By and large, this fleet has been designed to accommodate those kinds of spikes incredibly well, incredibly flexibly, and to provide very, very high performance no matter the sort of peer pressure that exists. We also have a service called Dedicated Instances, where if you want to be guaranteed that you are the only customer on a given physical box, you can pay us hourly, and we'll make sure that that's the case. In our cluster compute networks, again, we're on 10 gigabit full bisection non-blocking Ethernet connectivity, and really designed to move that kind of pipe at wire speed. So we've had a question that's come in about our forums, an important resource. Certainly want to make sure you're aware of forums.aws.amazon.com. A great place for asking questions, getting answers, getting sort of community feedback about your designs or other kinds of sort of implementation concerns. There's a question here about getting started and training and things like that. Amazon has just started with a formalized training program. We have classes for IT infrastructure architecture folks. We're in the middle of doing a class on Elastic MapReduce, and there are classes on sort of getting started, not only with Windows but also with Linux and other kinds of things. So lots of that kind of thing being started up, and also a lot of practices that are in place in some of the great systems integrators as they start to onboard not only their internal teams but their existing customers. Very, very useful, certainly, to set some time aside to get trained or to go through a self-education process to make sure you really sort of know how to use these tools. There's a question here about how servers connect with the LAN. I'm gonna expect that that's actually a question about connecting back into your local network that's at your data center. So a couple different options for that. You can use the VPC environment virtual private cloud. Includes a hardware VPN device. That's a pair of BGP IPsec tunnels that you'd use to connect back to a similar VPN devices on your side. You can also use software VPN. Not only sort of open source applications like OpenSwan or OpenVPN, but commercial applications as well for establishing that. That's a very very normal to build those kinds of secure connectivity back to your infrastructure. Using VPC, you can actually prevent all internet connectivity for a given virtual machine on EC2. You can make it so that that only connections over your VPN are the ones that are able to get into these instances. There's an important question here about Amazon machine images, about are there appropriate AMIs to use based on different app needs. Really, I think a critical question in terms of how it is that Amazon approaches validation and software deployment. The Amazon public AMI catalog is not stewarded, is not reviewed or evaluated. That's a place for our customers to share the work that they've built and to make it easier for them to share between their accounts or to their partners or other kinds of tasks like that. Amazon does not review Amazon machine images that weren't published by Amazon. So it's actually a much smaller list of Amazon machine images that we've built and stewarded. As you go through and pick an AMI, because we think that's a very normal use case to say, I want a Windows machine that has these two pieces of software on it. Maybe I don't have to go do those installations. Maybe somebody's already built it for me. I would only use an Amazon machine image that the author of that image is someone you have a relationship with, whether that's a third-party service provider. Bitnami and others have systems for publishing and building best practice encapsulating Amazon machine images. Certainly many of the ISVs, Microsoft and others have built their own Amazon machine images. Certainly makes sense to take advantage of those. As you move further out and you're getting to more and more obscure folks that you may not have heard of, that you don't have a relationship with, there's no validation on the contents of those AMIs, so very important that you evaluate them in a sort of secure setting. There was a question that came in about adding proprietary applications or commercial off-the-shelf applications to AMIs. It's exactly the same way as you'd do it in a physical environment locally. You'd be going straight to logging into the machine, remote desktop toing it typically, and then from there running your install process. Now remember, the machines don't have a CD drive, so very important that you're able to migrate the data by way of some kind of an image or to download from the application deployer's website, things like that. There's a question here that I think that's really great that says, sometimes, when these machines start to do weird stuff, like a normal computer at our local data center, if it just doesn't make sense, we go over and reboot it. We want to watch it do sort of a reboot cycle. That's one of the big sort of differences between us and more sort of packaged platforming environments. These are real machines. They're virtualized, but they're real. So you can absolutely call a reboot function on an EC2 instance. It won't move between virtual machines. It'll maintain the same IP address. It's very straightforward to run a reboot and then go in and take a look and see what it looks like after it's done a sort of a clean restart. That's also something that you can do programmatically because you can call the reboot function by API. Very, very easy to use, very useful service. There's a question today that's come in about certifications. Amazon's right at the beginning of building a certification program. So if you have any kind of feedback about that or any kinds of new ideas on what you'd like to be certified for or in what context that would work, Amazon's really eager to hear that kind of feedback as we make and design those new systems. That's a great piece of advice for all the different products. Amazon, again, is building these things very, very rapidly. So any of your feedback as to which features are critical, which systems are valuable, which items are blockers or enablers, which parts work and don't work are really important as we continue to iterate and build very, very powerful, very effective systems. There's also a very technical question, which I like, that came in about there not being enough hard drive space on the C drive. So at Amazon, we only give you what you ask for. So every virtual machine, typically that runs Windows today, there are a couple that boot off of S3. That's an older format called an instant store image, but most of them boot from EBS. An EBS image, you define how big that drive is supposed to be. That's called block device mapping. Every instance has its own block device mapping, and you can override that mapping either in our command line or our API tools in order to start a machine that uses exactly the same image ID as one that you've used before, but uses a different size disk, all the way up to a terabyte if you'd like. Very, very, very straightforward to make that change. We've gone through quite a few questions. Andrew, do you have any other critical ones that you think you'd like me to handle, or I think we've done a good job of sort of going through and catching at least most of the feedback that we heard through the webinar. I really appreciate everybody's questions on this thing.
Thank you, Miles. I think we've received quite a bit of questions this afternoon. Can't answer all of them, but we will be posting an archived version of this webinar on the same site that everyone has come to this afternoon, as well as these slides will be available within about 24 hours. So I'd like to wrap up today's presentation. Thank you, Miles, and thank you to everyone for attending today's webinar. So again, those who attended today's webinar will receive a follow-up email with a link to an archived recording of today's presentation, again, along with a copy or a link to a copy of the slides. I also encourage attendees to periodically check the events section of our website to see listings of other upcoming webinars or virtual events. Go to http://aws.amazon.com/about-aws/events. So on behalf of Amazon Web Services, thank you for joining us today to learn more about getting started with Windows on AWS.